if you're looking at the specific definition of factors, first of all, factors, the word factor are two things you multiply together to get a number. But when we're talking about factoring these things, you're basically asking yourself what numbers times themselves, what numbers times each other will give you the number. It's really much easier if you see it rather than do it there. For example, let's put some numbers down here. Here, write down this list all factors of, and I'm going to put a little colon because we're going to do a bunch of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what I'm asking you is, what numbers would you multiply together to get that number? And if you're listing all factors, you have to give all combinations. Well, the nice thing with 1 is you only have 1. The only way to get 1 is multiply 1 times 1. You really don't have any other options on that. The only way to get 2 is to multiply 1 times 2. The only way to get 3 is multiply 1 times 3. However, 4 starts to get to a different thing because there are a couple combinations for 4. And my strong suggestion to you on this is, in order that you don't forget something and you keep things ordered and organized, is always to write down the number with what times it gives you that thing. For example, you know that 1 times 4 gives you 4, but so does 2 times 2. You only have to list it once. But when I read the answers, I'm going to read them from the smallest to the biggest, so please keep them in order and you can do that. The number 5 is just 1 times 5, right? 6, we start getting into a few more. 1 times 6 and 2 times 3. 7 is just 1 times 7. 8 is 1 times 8 and 2 times 4. 9 would be 1 times 9 and 3. 10 is 1 times 10. What else? 2 times 5. 11 is 1 times 11. And 12, this one's going to go on for a little ways here. 1 times 12, 2 times 6, and 3 times 4. Those are just of the first 12. Again, the reason why you want to do a number with itself, because I can tell you when you get big numbers like 36, if I ask you to list all the factors of 36, I cannot tell you the number of times people know, well, usually they remember 1 times 36. But a lot of times they'll say, well, 2 is a factor of that, but they don't list what times 2 gives you 36, which is 2 times 18 gives you 36. As 3 times 12 gives you 36. And 4 times 9 gives you 36. And 6 times 6. So you've got 1, 2, 3, 4, 5, 6, 7, 8. 36 has 9 factors. You want to do everything that you can to keep those organized and make sure that you don't forget one, because if you forget one, unfortunately, it makes the problem incorrect. Another way the book likes to show this, and another thing that you can see that kind of talks about factors, and something that allows me to use the good old cloning thing here. Ready, clone? Have I cloned? Let's go clone with, let's do 12. No, let's just do 8. 1, 2, 3, 4, 5, 6, 7, 8. The book will ask you to do something with making rectangles and multiplication problems, and that means this. They will say this. If we look at 8, what are the different factors of 8? 1, 2, 4, 8. Well, that would mean if you take 8 blocks, how many different ways can you make a rectangle out of those boxes? Well, one way is to make a 1 by 8 rectangle, because 1 times 8 gives you 1 times 8 gives you 8. But there's another way to do it. What are the chances I could copy all this at once? Sure, why not? Another way I could make a rectangle out of that is to make not a 1 by 8, but a 2 by 4. And those are the only 2 ways that you can make a rectangle with 8 blocks. There is no other way to make a rectangle. If you have 3 blocks, there's only one way to make a rectangle, and that is a 1 by 3. You can't change anything or get anything other than that. So if they talk about rectangles and factors, that's what they're talking about. How many different rectangles could I have made with 36? Well, I could have done 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Looks like 5 or whatever I could have done. 5 different rectangles I could have made with that. Now, blank piece of paper. And on top of this blank piece of paper, write the word prime. Today's world with Amazon Prime, this would be a big number for you. A big. Prime exciting.
I love Amazon Prime.
What are prime numbers? Prime numbers are numbers that have exactly 2 factors. Exactly 2 factors. So going back to the list we made before of 1 through 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you think about what factors numbers had here, the number 1 simply had 1 factor, which is 1. So does that make it a prime number? No, because it has to have 2 factors. What did 2 have? Well, 1 and 2. Is that exactly 2 factors? Yes, 2 is a prime number. What gives you 3? It was 1 and 3. Is that exactly 2 factors? Yes, 3 is a prime number. What gave us 4? 1, 2, and 4. Is that exactly 2? No. 5 was just 1 and 5. 6 had 1, 2, 3, and 6. 7 was just 1 and 7. 8 had 1, 2, 4, and 8. 9 had 1, 3, and 9. 10 had 1, 2, 5, and 10. 11 was just 1 and 11. So it is also prime. So right there you have the first 5 prime numbers. And you have to do a little thinking. If I asked you, is 17 prime? Is the number 17 prime? You have to sit down and think, can I think of anything that goes into 17 evenly?
No.
No. So yes, it is a prime number. What about 15? Is 15 prime, yes or no? No. Why? Because what number besides 1 and 15 goes into 15? 3 and 5. How about 7,522? Is it prime or not?
Yes. Yes. Because it's even. No.
The answer, Colin, is no, because it's even. Right? Because every even number can be divided by 2 or has 2 as a factor. 2 is the only, it is the only even prime number. Because if you said, well, 88, I know that 2 times 44 gives me 88. So there are other factors to 88 besides 1 and 88. You could actually do this. If you cut this in half, what do you get? 3, 6, 7, 6, 1. 2 times 3,761 gives you this, so you know this is not a prime number. So any even number is going to be not a prime number. Let me see if they give you anything else here. Which one? Except for 2. Yeah, except for the number 1, isn't it? Wait, 1 is the loneliest number. 2 is second only to 2. So there you go. Those are your prime numbers.